Sweet. Let's go ahead and get started. Welcome to Tutor Tuesday, everybody. My name is Dan from Dan's Test Prep. Today we're going to be going over some SAT, ACT, and AMC math problems. I've got some fun ones in here for you today. While you're here, make sure to check out my Explore page, explore.danstestprep.com or join.danstestprep.com. And if you want any helpful SAT tips, I've got free videos on my TikTok, YouTube, and also a weekly newsletter. So let's see. The way it's going to work, we're going to go through some warm-up SAT problems, some AMC problems, and ACT problems. And if someone has questions to submit during the session, I will be taking those, and I have a few slots open here for those questions. So let's start with our first SAT question. This one says, which of the following equations is most appropriate linear model for the data shown in the scatter plot? Okay. What do you guys think in the chat? Alright. Maybe I'll come back to you guys later. For this one, I know that the slope is going to be negative. Hopefully you guys can see that negative correlation in this scatter plot of data. So I can instantly rule out C and D. And then if I'm looking at the y-intercept as well, where it intersects the y-axis, that's somewhere around positive 10. So it's got to be answer choice B. Not talking? Okay. Let me try to fix that. You guys hear me?
Guys hear me?
Should be going. Should be going now. Let me rejoin. Okay. You guys good now? Sweet. Back to the stream then. Number 15 here. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. Let's see, doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? Well, you can make like a little table for this. I think that's appropriate. Let's say we start with 300,000. And this was at 0 hours in. Let's make this like our time, and this is the amount. I think some of you guys in the chat can get this before I can, but let's do it in increments of 3 hours, right? Because it doubles every 3 hours, so it makes sense for us to do 3 hours, 6 hours, 9 hours, 12 hours, and 15 hours. So we started with 300,000. After 3 hours, we should have 600,000. After 6 hours, we should have 1,200,000, or let's call it 1.2 million. 9 hours, it doubles again, right? 2.4 million. 12 hours, another 3 hours has gone by, we double again. It's 4.8 million. And finally, after 15 hours, we double our last time and we get 9.6 million, which should be answer choice D. D, definitely. You guys are good at this. Let's do a little trig plot problem next. Basic trig. The measure of angle r is 2 pi over 3 radians. The measure of angle t is pi over 12 radians greater than the measure of angle r. What is the measure of angle t in degrees? Well, I know t is just the measure of angle r, which is 2 pi over 3, but it's plus 5 pi over 12 because it's 5 pi over 12 greater. And if I get a common denominator here, I can actually get that t is equal to 8 pi over 12. plus 5 pi over 12, 13 pi over 12. Now we just select the answer and it's not there because we want to find it in degrees, right? So doing this in degrees, we need to remember our conversion from radians to degrees, which is that you multiply by, there's 180 degrees for every pi radians. So we take that 13 pi over 12, multiply it by 180 degrees over pi, and what 180 divided by 12 is like 15, yeah, so we get 13 pi, pi over pi cancels out as well, so we get 13 times 15. What's that going to be, chat? There's only one answer choice that looks like it matches. C, exactly. 13 times 50, that times 15, that's our final answer. That's 195. Yeah, this is SAT math right now. And on the ACT, yes, you are allowed a calculator. Last SAT problem here that someone submitted to me, and then we'll get into some of the other questions. In the given quadratic function, a and c are constants. The graph of y equals f of x in the xy plane is a parabola that opens upward and has a vertex at the point h, k, where h and k are constants. If k is less than 0 and f of negative 9 equals f of 3, which of the following must be true? Either we get c is less than 0, or we get a is greater than or equal to 1. I don't know, what do you guys think? It looks pretty complex, so let's go through this step by step. I know that f of negative 9 equals f of 3. That's super important, I think. So that would mean that a times negative 9 squared plus 4 times negative 9 plus c has to be equal to a times 3 squared plus 4 times 3 plus c. C's, of course, can cancel out, but the rest of the stuff we can simplify. So we would get something like 81a minus 36 is equal to 9a plus 12. And if we add 36, subtract 9a, we could simplify this to 72a is equal to 48. Or divide everything by 72 to get a equals 2/3. So we have a definitive value for a. That's because they give us this condition. We have a definitive value for a. And notice how it's not greater than or equal to 1. So we could definitely rule out anything containing point number 2, right? Can't be B or C. 1 still might be true, but let's take a look at this. If our equation is f of x equals 2/3 x squared plus 4x plus c, we know that our k is less than 0. Just intuitively, I can kind of guess that the c value would have to be kind of low, like maybe below 0, but we don't know for sure. Let's try this out. So, c value. In order for k to be less than 0, I know that we can actually use our discriminant, because if the y value of our vertex is less than 0, at k value, that means the parabola would have to open up and cross at exactly 2 points. And remember that discriminant formula is b squared minus 4ac, which in this case is going to be greater than 0, telling us this equation has 2 distinct solutions. Of course, b squared is 4 squared minus 4ac. Well, a is 2/3, and c is actually just c. We want this greater than 0. So we get 16 minus 8/3 c is greater than 0. Move that all onto one side. 16 has to be greater than 8/3 c. Or I want to flip this around actually to get 8/3 C has to be less than 16. It's a little bit easier for us to read. And then multiply by 3/8 to get C is less than or equal to 48/8. Did I do that right? I think so. Which that can be simplified to C is less than, divide by 8, 6. C is less than 6. Actually, that makes point number 1 false as well. So the only correct answer here should be neither 1 nor 2 has to be true. We all good on that one? Yeah, if you guys have some questions to submit, send them into DMs or send an image in the chat right here. Hopefully that one was clear. I think we'll move to our ACT problems next. Those are always fun. So what do we got here? Number 49. Considering only positive integer factors, which of the following integers has an odd number of distinct factors? I'll let you guys take a second to look at this one. Hopefully nobody in the chat has already got it. D? You're saying D? Okay, see ya. Submitted. Yeah, can you send me an image? Okay, back to 49. Odd number of distinct factors. I think a perfect square should have an odd number of distinct factors, right? Because usually if you have a number like, say, 8, its factors 1, 2, 4, and 8, each one kind of pairs up with its counterpart. But if you have a perfect square like 16, it's got 1, 2, 4, 4, and I'm not going to count that twice, so it becomes like this. That 4 is what makes it special, the perfect square, because multiplied by itself, it it is not a distinct, it's not two separate factors. It's only counted once, which means these ones pair up, but then this one, it's just counted once. It's not distinct to count it twice. The other ones, I mean, you can list them out if you want. You could say like 1, for 20, for example, 1, 2, 4, 5, 10, and 20, but you'd see that it's even, and it's the same story for all the other ones. Sound good? C correct. Oh my. Yeah, it should be A. Is it distinct if it is distinct, it has two of the same number. If it's distinct, distinct factors means separate numbers. So if its factors were 1, 2, 4, 4, 8, and 16, these would not be counted as distinct factors. You would just count it once. That would be counted as a distinct factor. You can paste an image in the chat to submit the questions or DM me. Next one we got number 51. In the standard xy coordinate plane, the graph of the equation y equals 3 sine 2x plus 0.5 pi has what amplitude and period? Oh, you guys know this. It's just simple trig. Amplitude is going to be the number out in front here. Amplitude for sine is going to be how high it goes. And if it's got a 3 out in front, that coefficient is going to multiply sine so that it reaches a maximum value of 3. So it could be A, B, or C. And then for the period, we know that sine normally has a period from 0 to 2 pi, which means it would repeat right here. But instead, we've got a shortened period. Let me see if I can draw a good sine wave. So the amplitude is definitely raised up. We're hitting between 3 and -3. And the period is going to depend on the scale factor on x. This is a phase shift that doesn't have anything to do with it. But the scale factor on x, if normally our period would be every 2 pi, that's a normal period. If we're multiplying our x inputs by 2, alright, let me paste that question in. But yeah, we're going to reach 2 pi earlier if we're multiplying by 2 here. Actually, if we put in an x input of x equals to pi, this 2 would multiply that to 2 pi, and then we reach the endpoint of sine and start over. So the period is actually going to be every pi units, it's going to repeat, because we'll cover that whole circle of sine values from 0 to 2 pi. W, exactly. Paste this one in here for later. We'll do a couple more. 55. For all m such that, alright, so I know someone's going to get this like right away. ACT problem. Yes, I have that one next. Someone's going to get this like right away. But for all m such that 0 is less than m is less than 1, the value of m to -1 must be what? Alright, so that's 1 over m. And if you think of the graph of like 1 over x from 0 to 1, 1 over some number, it actually makes it larger. Like 1 over 2 makes this, oh wait, hold on. 1 over some number between 0 to 1 makes it larger. So like 1 over 0.5 makes this equal to 2. Or like 1 over 0.1 actually equals to 10. When you have these decimal values or really small fractions, putting it in the inverse actually makes it much larger. That's what we see here in this region of our function from basically 1 up to infinity. In this region of x's, your y values are actually always going to be larger. Or I guess generalizing this to m, if your m value is between 0 and 1, the inverse of m has to be greater than m. Oh, thank you. A? Yeah, definitely A. Heart react for that. Okay. Number 60, our last ACT problem. I think Oliver submitted this one last week, and I just put it in for this week. What is the matrix product of these two matrices? I'm actually doing some matrix stuff for my homework right now. Let's go through it. For matrices, we want to multiply. Let me draw it out. It'll be easier to explain. W, X, Y, Z. So I noticed that this one has 2 rows. This one has 2 columns. So the final matrix should also be a 2 by 2. 2 by 2. And I'm going to draw it pretty big to leave some space for computation. We're going to have 4 elements here in this new 2 by 2 matrix. And I can maybe label that right here, a 2 by 2 matrix multiplied by another 2 by 2 matrix. We're going to take those two numbers as our final dimensions, and this one's also going to be equal to a 2 by 2 matrix. To get this first element, we're going to multiply our, maybe I can even color code this, our first row multiplied by our first column on this one. And what that's going to look like is we're going to take this element times this one, so 3w, and we're going to shift our arrows over to the next element. We're going to move across the row on our first matrix, and we're going to move down the column on our second matrix. So then it's going to be plus 5 times y. And that's going to be our first element here. This element is actually a combination of, you could see, because this element is in the first row and the first column of this new matrix, I'm going to focus on taking the first row from here and the first column from here, and making sure I pick up all those values along the way. See, now this one right here, this element right here, is our first row, second column. So we're going to take the first row of values right here, and the second column of values right here. So that's going to be 3 times x plus 5 times z. What do we got next? Second row, first column. So that's second row, first column. Second row, first column. It's kind of like FOIL almost, but it's just a little bit more complex. 6w, right? The first elements are 6 and w, then we multiply 8 and y. And you could probably see the answer already, but let's do the last one. It's the last row, last column, or second row, second column. So it's going to be this row and this column. It's going to be 6 times x. If we shift over, then we get 8 and z. So plus 8z. And that should match up with answer choice J. How did I do? J, nice. J is good. Oh, that's a lot of problems in here. Thank you, thank you. I see a lot of problems. Okay, let me go through. I have space for 2 more of these community questions. So let me pick a couple out. Do that one. Wow, it's huge. And I have space for 1 more, so send your favorite. You have homework? Yeah, I got my degree and I'm doing a PhD now, so I have to take grad courses. Okay, this one looks cool, so I'm gonna do this one. Thanks. Probability, yeah, definitely probability will show up on the SAT. Not that often. I picked out these 3 community questions for today. We're gonna do just those 3 since we don't have a ton of time today. We still gotta get through our AMC problems. Let's see, how many solutions exist to the equation absolute value x equals absolute value of 2x minus 1? You could honestly graph this out and tell, and that's what I'm actually going to do to validate my solution. But just from first glance, I'm guessing it'll be something like, no guesses. Let's just solve it out. We have absolute value x equals absolute value of 2x minus 1. So what this could mean is that we could have several cases here. Could have x equals to 2x minus 1 is one case. And that's the case where everything in the absolute values is positive, we could have the case of negative x equals 2x minus 1. It's another case where uh, everything's positive except for that first part. We could have x equals negative of 2x minus 1. So in this case, this side's positive, this side's negative, and we could have x or negative x equals negative 2x minus 1. So those are the four cases we could potentially solve out and see what we get. Let me label them. So case 1, if x equals 2x minus 1, we can add 1 to both sides, subtract x, we get x equals to 1. For case 2, we could write in negative x, there's case 1, case 2 right here, negative x equals 2x minus 1, we can add 1 to both sides and add x to both sides, divide by 3, x equals 1/3. For case 3, we have x equals to negative 2x plus 1. I just distributed the negative. We can add 2x to both sides to get 3x equals 1 and divide to get x equals 1/3. Well, that's just the same thing as this one, so it's not a distinct solution. And the fourth one, if I have space, I'm going to do it down here. Negative x equals negative 2x plus 1. Actually, that's the same thing as this, except you just move everything onto the other side, and you can rewrite this as 2x minus 1 equals to x. That one's also the same thing of x equals to 1, so that's not distinct. So two solutions. We get two solutions. We get x equals 1, and we get x equals to 1/3. Clear on that one? Sweet. Got two more questions here. If I equals square root of negative 1, what is the product of 4 plus 7i and 1/2 minus 2i? Okay. 4 plus 7i. Well, actually, this just looks like a FOIL problem, just distributive method. So let's do this. 4 times 1/2 is going to be 2. 4 times negative 2i is going to be minus 8i. 7i times 1/2 is plus 7/2 I. And then plus 7i minus 2i is minus 14i squared. But of course, since I equals the square root of negative 1, if we do I squared, we get back to negative 1. It's going to be 2. Let me also convert this into 16i over 2 plus 7 over 2i. And then minus 14 times I squared I've replaced with negative 1. So that becomes plus 14. So in total, it's going to be 2 plus that 14, which is 16. And it's going to be minus 9i over 2. So that should be answer choice A. We love FOIL. Okay, number 5 here. I'm going to paste in the question so you guys can see. Yeah, thanks for pasting those answers. I know sometimes the stream is weird. If 18 over r plus 10 equals 3 over r, what is the value of r over 3? Well, I would take the reciprocal. Actually, I still am going to take the reciprocal because that would get me r plus 10 over 18 is equal to r over 3. Now if we just need a value for r here, so you could kind of guess and check here. That might be valid. Like if I plugged in, okay, let's actually solve this out. If I multiply by 18 on both sides here, times 18, that times 18. Then we get r plus 10 is equal to 6r. It just becomes a linear problem. Right, so subtract r from both sides, we get 10 is equal to 5r. And then r is equal to 2 once we divide by 5. So who said C? Because that would be wrong. Because we want to find the value of r over 3, which is equal to 2 over 3, plugging in that r equals 2 up into here. So finally, we get a solution of answer choice A. A, okay. You guys are good. I think I covered my community question slots. I'll paste in you guys' questions for next week, whoever didn't get a chance to get theirs answered, because I've got some AMC problems for you guys now. This first one says, what is the value of 11 factorial minus 10 factorial over 9 factorial? Let's see how quick some of you guys can get this. Reading prep, maybe. Let me do a little poll. You guys give me your, okay. No, you're amazing. Hey, someone said B. B's correct. Let's go through why. I know that 11 factorial is just equal to 11 times 10 times 9 and so on, or just 9 factorial. 10 factorial is also equal to 10 times 9 factorial. And if I factor out a 9 factorial on the top, then I could get 11 times 10 minus 10 all over 9 factorial. That's very nice for us because those numbers cancel out. And then we're just left with 110 minus 10, which ends up being answer choice B, as you guys said. Sure. For those of you guys who don't know, the factorial is just defined. Let me do a different color. Factorial is just a shorthand way of writing repeated multiplication of a decreasing number. So if we start with a number n, for example, then it's going to be n. N factorial represents the quantity n times n minus 1 times n minus 2, and so on until we multiply by 1. So some examples could be something like 5 factorial is just 5 multiplied by 4 times 3 times 2 times 1. 2 factorial is just 2 times 1. 1 factorial is 1. And 0 factorial is also 1. And we could also write factorials as other factorials because they're all kind of nested, right? So 10 factorial is equal to 10 times 9 factorial, which is the property that we actually used for solving this one. Can't see a screen. Okay. You know, I will be recording this and posting this for you guys who can't see, but Money Treehouse has been doing real good posting all the answers. Our next one here, I'll paste in the question, but you've got the answer. For what value of x does 10 to the power of x times 100 to the power of 2x equal 1000 to the power of 5? Let's see, this is 10 to the x. 100 can be represented as 10 squared. So it's 10 squared to 2x. And 1000 is represented as 10 cubed. So that's 10 cubed to the 5th. Now, this can be simplified. We get 10 to the power x times 10. And then when we have exponents being exponentiated, we multiply those exponents. So or 10 to the power of 2 to the power of 2x, that becomes 10 to the power of 4x. 10 to the power of 3 to the power of 5 becomes 10 to the 15th power. And of course, when we're multiplying two bases with the same, or sorry, multiplying two bases, same bases, then we add the exponents. So then this becomes 10 to the power of x plus 4x, or 5x. At this point, I think you guys can see where we're going with this. We want to equate those exponents since the bases are the same. Well, otherwise we get 5x equals 15, and x should be equal to 3. Who got that? D? E? Guys, I don't know. I got C for this one. I think I know Oliver would agree. Looks like you guys are all in favor of reading prep, so maybe I'll throw in some reading prep next week. Scroll down. Yeah. There you go. Sweet. It's C. Oliver knows. Alright, what's our next one? The mean, median, and mode of the 7 data values. Oh, I should probably paste the question, huh? Oh, he's got it. He's got me. The mean, median, and mode of the 7 data values, 60, 100, x, 40, 50, 200, 90, are all equal to x. What is the value of x? Probably mean or median would be easiest. Let's see if we can do this using the median first, because I don't really feel like calculating the mean here. For the median, we would want to organize these in order. 20 is the, wait, oh, I could have sworn there's a 20. 40 is the smallest of that we know. Then we go to 50, then 60, 90, 100, and 200, with the value x being stuck somewhere in here. We don't really know. That's what we're trying to figure out. Well, if the median is x, then I know it's got to be stuck right in the middle here. Actually, yeah, that basically solves out the position for us. X needs to fall right in the middle here, so it has 3 values on its left and 3 values on its right. That could mean that x could be either 60 or 90 from this information so far. Because we need the mode as well as the median to both be x. And for the mode to occur, we'd need one of these values to occur twice. Okay, so maybe I do have to calculate out the median. I mean mean, which I could have just started with. Anyways, the mean is just going to be 60 plus 100 plus x plus 40 plus 50 plus 200 plus 90 all over 7 items equals to x. Okay, so that's going to be 160, that's going to add up to 200, 400, 450, and 540. So 540 plus x equals to 7x. We multiply by 7 on both sides, and we add up all of our constants. Or 540 is just equal to 6x. And you could see now, dividing by 6 here, we're going to get, what is it guys? 90 equals to x. So at least our initial guess was kind of close. It's either 60 or 90, but using the mean really narrowed it down for us and gave us answer choice D. Yeah, W. Always W's. Last one looks fun. Okay. Looks kind of long, but let's get through it. Goldbach's conjecture states that every even integer greater than 2 can be written as the sum of two prime numbers. For example, 2016 equals 13 plus 2003. So far, no one has been able to prove that the conjecture is true, and no one has found a counterexample to show that the conjecture is false. What would a counterexample consist of? I mean, it's kind of in the name. It's an example that counters the original claim. So if the claim is that every even integer greater than 2 can be written as the sum of two prime numbers, that is our claim. If we found an example of a number that was, or an even integer that was greater than 2, and it could not be written as a sum of two prime numbers, that would prove counter to our claim. So looking through this, an odd integer greater than 2 can be written. Well, it doesn't say anything about odd integers. Even integer greater than 2 that can be written as a sum of two numbers that are not prime. That's not really the claim here, or doesn't really counteract the claim. I'm focusing on this word can right here. Can be written as a sum of two prime numbers. This doesn't say anything about whether it can or cannot be written as a sum of two prime numbers. It's just going to a different claim about whether the numbers themselves are prime. Even integer that can be written as a sum, well, that's just the original claim. So E is our only choice. If we found an even integer greater than 2 that cannot be written as a sum of two prime numbers, that would counteract the very claim that we've put forth here. Sweet. W. Here. Ooh, I think that was a good set of problems. I've got to head off a little bit early for tonight, but I'm glad you guys could join. Let's do some reading prep next week. Don't forget to check out my Explore page, or if you want to sign up for my newsletter, I just have a simple join page for you guys. And thank you guys for joining. Submit some questions for me for next week. I'm going to look through all the ones that I missed from earlier in the session, and we'll do those next week. Sweet. All right. I'll see you guys later.